Guardrails, a lot of behind-the-scenes action that you're involved in all the time. Motorists drive by many guardrails and never notice them. But if one of those motorists ever requires the need of this safety net, it's there.
When I first arrive on the scene, I think about what's happened to the person that's been involved in the accident. How badly was he hurt? If there's anybody else with him, how badly they were hurt? How badly the vehicle was damaged? You know, you look at that stuff and you see the A10 posts sheared away, and you just wonder how badly the person was hurt inside the vehicles.
In many instances you hear where the people have survived, you know, the crash, and there's a big ravine down below, you know it's done its job, and that's what counts.
Several things are involved in creating a safety net of guardrails. We're going to be talking about three of those things: the design of guardrails, the testing of those designs, and the maintenance, restoring a system after it has sustained damage. When you realize all the elements engineers have to consider when designing a safe guardrail system, you begin to appreciate that structure that needs the flexibility of a rubber band. Regardless of the size of the vehicle, how fast it's going, or the angle of impact, the goal of the guardrail system is to yield just enough so that the car ends up next to the structure along the shoulder.
We basically use one guardrail system where we have traffic at a design speed of greater than 40 miles an hour. Where the design speed is less than 40 miles an hour, we do not use guardrail.
There are three basic kinds of guardrail: a soft or flexible system, a semi-rigid system, and a rigid system. We're going to be discussing the first two of these systems: the flexible or cable system and the semi-rigid or plate beam system. The cable system is used primarily in rural or low-volume areas because it's cheaper to install, it doesn't create snowdrifts, and its design allows for greater deflection, which is conducive to rural conditions because the obstacles in these areas are generally further away from the roadways. In contrast, the plate beam system is primarily used to protect vehicles and passengers in high-volume urban areas from obstacles which are greater in number and closer to the road, or in high-hazard areas such as approaches to bridge abutments. Because its rigidity controls the amount of deflection, the plate beam system is also used because it can still function after impact. Each of these two systems has the design elements which are crucial to the goal of safely redirecting a car and its passengers. The more rigid the system, the more rigid the post must be. It is crucial to design the right size posts and to use the right kind of material. Once the right material is determined, that material is used on all the posts. You don't mix types of post material. The bolts connecting the plate beams also provide strength to the whole system. The end on a plate beam system is twisted or bent down in order to prevent serious injury to the passengers in the car. If left out, the end piece could easily pierce the vehicle and impale the passengers in the process. In the cable system, the posts and cables need to be strong enough to hold the car in, yet flexible enough to redirect the car. Both the strength and the flexibility must be in the right balance. The anchors are designed to provide strength to the cable, hold the cable in place, and keep the tension tight. They're buried so that they do not become an additional hazard to the motorists. The height of the cable is also important. If the cable is too low, the car will go over the barrier, and if it is too high, the car may go under the barrier. In the plate beam system, the posts need to be more rigid. The more rigid the system, the more rigid the post must be. The proof of a good design is in the performance of the entire guardrail system under crash conditions. Vehicles that go through the barriers, overturn, jump over or around the barrier into another lane of traffic, or hit with a force that causes damage to the vehicle or injury to the passenger reveals a flaw in the guardrail system. Different tests focus on different elements in the system because the designers realize that just one element can disrupt the whole system and cause injury and destruction to passengers and vehicles. The problem may lie in the balance of strength and flexibility of the cables or the plate beam, in the bolts that attach the cables to the post, in the depth and positioning of the anchors, in the size, number, or type of posts, or in the slant of the end piece. The whole system must provide the right balance of strength and flexibility in order to prevent a vehicle from snagging into part of the system or being forced over, under, or around the system with such a force that serious injury and extensive damage are likely. The right balance provides passengers and vehicles a continuity of movement at a speed and distance that provides safety. A guardrail system is ready to be installed when this performance standard is met. At this point in time, the crash test conditions and the mannequins in the vehicle are history. The guardrail system must now be ready to adequately function in real time with actual motorists. The third phase, the maintenance phase, involves restoring a damaged system back to a functioning system that is safe.
If it's been weakened by previous accident and not repaired, and I guess that's why you'd have to make sure it's repaired in that same structure that it was, to the same strength. Because if it wasn't, then you would have a weakened situation and the guardrail wouldn't be effective.
That's why it's so important to walk through an entire system that's been damaged, to check out not only the visible damage, but the alterations that have occurred in different parts of the system because of the impact or impacts it has sustained. Bolts in the plate beam may have been bent, and the holes for the bolts, although still straight, may have been stretched. Both conditions require repair because holes that have stretched will not provide the strength needed for the next hit. All of the anchors have to be checked. Damaged posts and cables have to be replaced. Cable splices have to be checked as well as the turnbuckles. Only when you have checked and repaired each element in that system do you know that the system is adequately prepared for the next motorist. You are often in the best position to observe when a guardrail system should be removed because the hazard is no longer there. Perhaps a sign has been removed or a steep shoulder slope has been leveled. Because a guardrail is a hazard in itself, it is important to mention when one no longer seems needed. In addition, it is also important to repair a partially damaged system to its original configuration because restoring to new standards may affect the functioning of the system. Again, mention should be made to a supervisor to determine if a change to new standards is merited at a future date.
You know, you are putting something up there that's doing somebody some good. You know, it is not up there for looks. It's there for a reason.